Okay, so I'm now going to show you how to calculate Mn with compression steel. And remember, there's two cases, AS yielded, and the other case is AS prime not yielded. And within AS prime yielded, the compression steel yielded, you have two options. One, you can use the basic equations of T equals C, solve for A, and then sum the moment about the tension steel. And then a second option that's popular in many books is to break the beam up into a steel couple and a regular reinforced concrete beam. We'll cover both, and I'll do this one first in this video. There is also later going to be AS prime not yielded, so there's going to be three videos. One, yielded using basic equations. Two, yielded by breaking up the beam. And three, the third video, AS prime not yielded. And when it's not yielded, the big difference is that the stress is not Fy, it's just E times the strain. And then you're going to get the strain from similar triangles. I'll go over this, okay? And once you know that, you can get the compression force. And then when you solve for A, you actually solve for C, you get a quadratic equation. And it makes it a little more difficult. Put that into the quadratic formula or solve it numerically on your calculator, but it's all for C. And then you do the same thing, you solve for M about the tension steel. So this first one is going to be AS prime yielded, and using the basic equations, T equals C, solve for A, and then taking moments about the tension steel. Okay, so in this example, it's yielded. I've done it ahead of time, and I know that this one is yielded. Up here, you have two number 7s, and down here, you have 6 number 8s. And so you can see, look at the difference. This is 4 times AS prime. And so the AS prime is small. So we're going to guess that it's yielded. Okay, so because we know it's yielded, since we guessing that it's yielded, is Fy times AS prime, which is 1.2 square inches times 60 is 72 kips. The bottom is always yielded, so AS times Fy, so 4.74 times 60 will be 284.4. And so, and then we have, of course, we still have the compressive force due to the concrete. So we'll just do T equals C. There's the T. That's C of the steel. And here, as usual, is C of the concrete. 5 F prime C times the area, which is just B times A. B in this case was 11 inches. So you just, and F prime C was 3 KSI. And if you plug in all those numbers and solve for A, you get A is 7.57 inches. And C, because remember A is beta 1 times C. C is A over beta 1. And that's 7.57 divided by 0.85, which is 8.9 inches. Now, we need to verify that our assumption that AS prime yielded is true. It is, because at the ahead of time, but you don't know that. So we have to do that. And what you do is similar triangles. So we just found that C was 8.9 inches. So let me draw the whole beam so you can see where that comes from. There's the tension steel. Remember, we said the strain in the concrete of failure was 0.003. There's 8.9 inches. And the strain diagram looks like that. You have steel up here. And that's going to be the strain in the compression steel. So this top half of the triangle here is drawn right there. Okay? And what we're trying to do is find this, okay, by similar triangles and knowing that that's 2.5 inches. And so I skipped a lot of the math, but what you have is epsilon in the compression steel. So we're going to basically do this triangle and this triangle. Okay. So epsilon of the steel prime for the green triangle is to 6.4, 8.9 minus 2.5 equals 0.003 to 8.9. And then solving for that, you get this. And remember, epsilon y for grade 60 is 00207. So 0022 is greater than 00207. So yes, it's yielded. So we were correct in assuming that was yielded. So this is true. This compression force here, okay, in the concrete is 0.85 F prime C B times A. Okay, so F prime C was 3, B was 11, A was 7.57, not C, 7A. D, 22 and a half. A was, A was 7.57. Oh, yeah, I had that earlier. D, 22.5. D prime was 2.5. And trust me, you plug all that in and you get 5414 inch kips, and FMN you multiply 0.9 divided by 12, you get 406 foot kips. So there you go. This next example is making them into 2 separate beams. We'll do that next, but it's not that hard, right? Just T equals C, solve for A. The only trick was this right here. You have this extra compression force due to the steel, and if it's yielded, that's actually quite easy. It's just the area of the steel times Fy. Then you just solve for A, and then the added thing is you have to make 2 moments. One is 72 times this distance, which was D minus D prime, and the regular concrete force times that distance, which was just D minus A over 2. Okay, so the next video will be if it's yielded and how to do it with this, breaking it up into 2 different beams, and we should get exactly the same answer. Okay, so that's the next video.